Hello world, it's Sumit and welcome back to my YouTube channel. So today's topic of discussion would be feature scaling, which is a very important topic as part of an pre-processing of your data. So let's look into the topic, like what we're going to cover up in today's session. First would be feature scaling, where we're going to discuss about like what actually it is and what are the importance of using it. Then we're going to see the different types of feature scaling, such as data standardization and data normalization, and how and when we have to use this. And then we're going to compare the difference between them theoretically, and in which case you need to use this and what are the scenario can be applied for both of them. And at last we're going to jump into the code snippet to see like how using different scikit libraries you can simply call this and we can use this in our code. So let's begin with the feature scaling first. So feature scaling is just a technique to standardize the independent feature that is present in your dataset in a particular fixed range, and it is performed during the pre-processing of your data to handle high varying magnitude and units. Why I say magnitude and units? Because feature can always be represented into two aspects, that is magnitude and unit. Let's say I got a few feature as feature 1 which lies in the magnitude of -1 to -5, and it can be measured upon in centimeter, which could be its unit, and feature 2 lies in the range of 100 to 500 and it can be measured in kilometer, while the feature 3 lies in the range of 10,000 to 50,000 and it can be measured in liter. So you can see like all these three features have different units and the magnitude of the range, which is it's very different. So this lies in the range of -1 to -5, whereas feature 3 lies in the range of 10,000 to 50,000, and it's a very high difference of the magnitude of the range between these two feature. Second point is we cannot compare feature 1 and feature 3, or either we cannot compare feature 2 with the feature 3. We can compare feature 1 and feature 2 because both can be in centimeter, millimeter, and this is in kilometer, and this is in liter, but you can compare centimeter with kilometer, but you cannot compare kilometer with liter. So you cannot justify that. To handle this kind of scenarios, we always scale it up to certain values or in a particular fixed range, or to make the feature to comparable in certain standard deviation. If feature scaling is not done, then the model tends to weigh greater values higher and consider small values as very low values, regardless of its unit and magnitude. So basically there are two different types of feature scaling. First is data standardization and data standardization. So data standardization is just a technique where the values have been centered around the mean, where the mean of the attribute becomes 0 and the resultant distribution what we get out of it has kind of a unit standard deviation. Let's say I got my raw data with me, and this raw data says about this feature 1, feature 2, feature 3 and feature 4. If I'm going to plot this using any of the matplotlib, then we're going to get this as feature 1, feature 2, feature 3 and feature 4. If feature 1 can be represented in kilometer and feature 3 can be represented in liter, which could be its unit, and the magnitude of it lies between 0 to 25, where this lies in some sort of negative value, where the feature 3 lies between like 100 to 200, and this lies in kind of 0 to 40. So we can clearly see if I have to compare this to value, or if I have to compare feature 1 and feature 3, I cannot compare both of them. First difference is like this two have a difference of the unit. We cannot compare both of them, or we cannot justify the relation between this kilometer and liter. Other thing is we got some kind of a negative value with us, like in feature 1 we got in feature 2 we have a negative range of value, and in feature 3 we have high magnitude range of the value for the issue. To handle this kind of issue in our raw data, we use data standardization, and after doing data standardization we can clearly see the mean of the attribute becomes 0 and the resultant distribution what we get has kind of an unit standard deviation, so that we can compare all of the feature at once. So this data standardization is very useful for the data where we have sort of negative value and the difference of the unit with us, and it is more useful in So next part of feature scaling is data normalization. So this data normalization is a kind of scaling technique where the values have been shifted and rescaled so that they end up lying in the range of 0 to 1, and it is also known as mean max scaling. So let's see the example of this. Let's say I got my original data, the same data what we had got in the previous example we got, and the feature 3 lies in the range of near about 200 to 200. So if I have to compare this both of it, like the feature 1 and feature 3, it cannot be comparable because of high magnitude of varying range. To avoid this kind of issue, we normally do data normalization, where after scaling up with data normalization, once we got the output would be always be in the range of 0 to 1. Previously we have in the raw data we have 0 to 250, but after scaling up with data normalization we get up in the range of 0 to 1, and you can see like all the feature which were there, which were present in our data, is been in a range. Important thing to note here is like even after doing with the data normalization, it's only changed the magnitude of it, while it will going to preserve the unit of it, meaning feature 1 could always can be measured in kilometer, while feature 3 can be measured in liter. So normalization is very useful when you know that your distribution is not following any kind of a Gaussian distribution, and it excuses the data in range of 0 to 1 due to the decreased range of the magnitude. What we get as an output, the gradient in the training process do not explode, and it doesn't give you higher value of losses. So again, this was all about. Now we'll to visually compare both of it, like how both of it is different and when we have to use it. So first thing is, like when we got the original data, what we had learned is when we got the original data where it can be of some different magnitude and it can be of some different unit, like the feature 1 is in kilometer where the feature 3 is in liter. Then after performing using the data standardization, the output what we're going to get, it would be centered around the mean with kind of an unit standard deviation, whereas in data normalization the output for what we're going to get, that would be lying up in a range of 0 to 1, and it is preserving the original data in form of unit. Like this, the feature 1 we can measure in kilometer, where the feature 3 can be always been measured in liter. So this is a major difference between two of it, and to sum up everything, in data standardization it could be always be centered around the mean. It doesn't preserve the original data, meaning in form of unit, because it always tends to convert it to unit standard deviation, and it is known as standard scaling. While in case of data normalization, it always scale up your values between range of 0 to 1, and it do preserve the original data in form of original deviation, and it is known as mean max scale. So after learning the major difference between data standardization and data normalization, from the coding perspective we're going to dive into deeper, like how we can exactly use this while coding in Python. Let's say I got a data set where I have 3 columns: the price, feature 1 and feature 2. So the price is my dependent variable which I need to predict the future price of it, and I have feature 1 and feature 2 which are my independent variable. So this feature 1 lies in the range of, for this 5 given data set, it has been lying in the range of 999 to 1000, and whereas the feature 2 has been lying in the range of 999.844 something to 1001. So if I have to plot this in a diagram, it will going to look exactly like this. So you can see there are more denser data points around in range of 999 to 1002, whereas few outliners also present. To perform data standardization over this feature 1 and feature 2, we just simply need to, from the sklearn library, we need to import standard scaler, where from the standard scaler we need to create an object of it. Once we create the object of it, from that API, from that object we used to call this fit transform API, where we're going to pass our independent variable train data set, and this train data set would be having my independent variables such as feature 1 and feature 2. So once we do a fit transform over it, our scaling of standard scaler is done. So now we just need to simply validate it, how it will going to look at. To see that, in that we are going to take that in a data frame. We are going to take that, like whatever we had got as an x train ss, like which is my custom variable. From this we're going to create a data frame out of it using pandas, where the columns which I'm going to make as a custom column as feature 1 and feature 2, standard scalar feature 1 and standard scalar feature 2. Once my data frame is created, I'm going to plot this using Seaborn, and it's going to look exactly like this. So now you may notice that it's lying in the range of -3 to 3, which is kind of a fixed range, whereas the important part to notice that all this has been, most of the data range has been scaled up to been centered around mean, and this range has been lying in the range of -3 to 3. Previously it was lying in the range of 997 to 1002, so it had got scaled down to a range of -3 to 3, with this centered around as mean as 0 and have kind of a unit standard deviation. So similarly for this data normalization as well, we need to follow the same exact step. So that would be around the, instead of standard scalar, we're going to import mean max scalar, and from this mean max scalar we need to call this API fit transform, and we need to pass extrain dataset over it. So once we pass it, it will going to give a scale value, it will going to do a kind of a scaling, and it will going to return me the mean max scalar of it in extrain MMS. So now we're going to take that in a data frame, we're going to assign a custom columns to it like mean max scalar 1 and mean max scalar feature 2. So these are my custom columns, and for this custom columns I had just passed my independent variable, so and created a data frame out of it. So once my data frame has been created, I'm going to create a strip plot using the Seaborn, and it's going to look like this. So this is my normalization. So now you may notice all the range which was lying in the range of 997 to 1002, it has reduced to be in range of 0 to 1. So all the values which are present in my data set is been in range of 0 to 1. So this is a major difference between standardization and normalization, and this is how we perform it. So the point of concern here is, like, over my independent variable for the train data set we had used fit transform, whereas for the independent variable which are there, independent feature, for those unseen data or the test data we had did transform. Why do we do that? Because fit transform API is always kind of learn the scaling parameter, which would be my mean and the variance, and based on that scaling parameter which I had got learned, it's going to scale the data. Whereas this transform, what it does like it always transform the data learned from your training data set parameter, like what you're going to use that scaling parameter to transform the data. So that's the major difference between this fit transform and transform. I hope I had made myself clear on this data standardization. Summarize up everything what we had learned today. First thing was feature scaling. We learned about what exactly feature scaling is, and in what aspect features can be represented, and how many types of feature scaling are there. Then we talked about data standardization, where we learn like what exactly data standardization is and how easily it can be known. And third, we talked about data normalization, where we understood graphically how we can learn that. And at last we compare both of them to know their basic difference between them, and while coding in Python how exactly we can use them. So this was all about today's session. So if you really liked my video, please do like, share and subscribe Cupla on my YouTube channel, and hit the bell notification icon for any new video update. And you can also give your feedback through comments, which could help me to improve on my video, to come up with more videos like this.